to them.
There are two types of motors, brushed and brushless. Brushed motors have brushes that deliver the electric current to the motor windings through contacts on the commutator. A brushless motor uses a commutating device like an optical encoder to energize the windings and trigger the fields. Very much the same as a three-phase AC motor, but with a different sine wave. A brushless motor consists of a bell or can, stator, shaft, bearings, and a commutating device. The bell contains permanent magnets along its inside diameter, and the stator has electromagnets. Turns of copper wire over a rotor tooth are energized to create a magnetic field that attracts or repels against the permanent magnets on the bell. The electrical current is triggered and routed by a controller to different sets of the windings to create and maintain that electromagnetic force, which turns the shaft. There are different types of ESCs for brushed and brushless motors. Brushless ESCs basically convert a DC power into three-phase power. They are programmable for specific user needs such as low voltage cutoffs, timing, acceleration, and braking. Reversing the wiring on an ESC will reverse the direction of the motor. It controls and regulates the speed of electric motors as it interprets a speed signal from the flight controller and varies the switching rate of a network of field effect transistors, or FETs. By switching the frequency or duty cycle of transistors, the speed is changed. The ESC uses a technique called pulse width modulation to encode a message from your flight controller into a pulsing signal. It basically turns the power switch on and off at a very fast rate. An ESC will have an 8 or 32-bit microcontroller unit processor which runs a firmware such as BLHeli and supports ESC protocols like the latest D-Shot or ProShot. ESCs are rated in amps and may have an integrated BEC, a battery eliminator circuit. An ESC must be able to handle the voltage and current input of your LiPo batteries. They can be a standalone unit, a 2-in-1 or 4-in-1 set that is integrated into one board which can be stacked on other boards for cleaner wire management. An ESC must be rated for the maximum amps of the motors you are using. The size and weight of an ESC is proportional to the amp rating. The PDB, or the power distribution board, is the heart of your quad. It takes your main power supply and distributes it to each ESC and other components. It is a basic circuit board that allows you to solder or connect all your components in an organized fashion. Some boards will have an integrated voltage regulator, or a BEC. This allows you to safely power auxiliary equipment like LEDs, buzzers, and FPV systems. Factors to consider: the current rating, the number of connectors, and the voltage regulator. Multi-rotorcraft have numerous motors to control at once. To individually control each motor and fly with balance and precision is impossible for most humans. Flight controllers come in a diverse range of complexity. Some are programmable and configurable circuit boards with an array of sensors that take a pilot's input and determines the appropriate RPM to each motor to manipulate the craft accordingly. They contain a range of sensors to supplement their calculations. These sensors can be gyroscopes, barometers, GPS units, and image sensors. The flight characteristics of a quadcopter can be adjusted and tuned with various software depending on your needs. Configuring your flight modes, gains, PIDs, OSD setup, etc. can all be done by connecting your flight board to a program like Betaflight or CleanFlight. The majority of toy-grade quadcopters have a plastic frame. Higher-end quads may use aluminum or even titanium alloys as a frame material. Hobby-grade quadcopters use carbon frames with a thickness from 1 to 6 millimeters. They come in a variety of sizes, thickness, and styles. A good frame will find a balance between weight and strength. Frames are available in a monobody or unibody, which is cut from one single piece of material. Other frames use separate pieces for the arms and the body, which are fastened together with hardware. The advantage of this is if you break an arm, you don't have to get a whole new frame. The RX receiver receives the input radio signal from your transmitter and applies it to the ESCs or other components appropriately. It must be compatible with the make of your transmitter. The TX, or the transmitter, is the control or input device that communicates with radio signals to the receiver. Transmitters come in a variety of styles and quality. Adding a compatible receiver to different quads will allow you to use one controller for all. The VTX transmits a video signal back to your goggles or FPV screen. They come in standalone units or can be integrated with an FPV camera. They contain an antenna, LED readout, and a button or switches to change the frequency, bandwidth, and power output. VTXs are rated by their power output in milliwatts and can range or be switchable from 25 to 600 milliwatts. When flying in groups, the 25 milliwatt setting is recommended so you don't overpower and bleed out another pilot's signal. When set at higher outputs, like 600, this component can get very hot. Propellers are what create the torque and upward thrust that make our quadcopters fly. The thrust to weight ratio, or the TWR, indicates the thrust you need relative to the weight to keep your drone hovering. The general rule is a 2-to-1 thrust to weight ratio. Torque is generated by the difference in rotation between all the propellers. By changing the RPMs of individual propellers, the yaw rotation is created. Newton's third law states that every action must have an equal and opposite reaction. That is why propellers on a quadcopter rotate in different directions. Pitch, size, and the number of blades all affect their performance. They are generally made of a plastic compound. There are also carbon fiber and foldable propellers. Antennas extend the range of radio signals and are a vital component for FPV systems. They are either tuned to 2.4 or 5.8 GHz frequencies. The 5.8 GHz frequency is the most common type in hobby-grade quadcopters. Polarization is an important characteristic to consider. Linear and circular polarized antennas exist, providing two different effects. Linear, a signal is broadcast at a very good range on a concentrated single plane. The disadvantage being you must be aligned with the signal. Circular. The signal is dispersed in a circular pattern, allowing a multi-path signal which isn't as strong but has more overlap or signal area. This prevents signal breakup when there are objects in between the path of the signals. The gain is another factor to consider. This is the intensity of your antenna measured in the unit decibel. Increasing the gain will stretch the signal pattern, while lowering it will compress it. Another classification is directional and omnidirectional. Directional antennas will give you the range but only in a narrow beam of coverage, while omnidirectional antennas will give you more coverage but at the cost of a weaker signal.